Good evening, everybody. I'm Lokesh MM. I'm currently doing my second year in SAP and University. I'm very much elated to welcome architect Prithviraj. He completed his B.Arch degree from SAP in 2016 and pursued MSc in Building Technology, specializing in facade and climate technology from TU Delft, Netherlands. He is working as a building performance analyst for the past 2 years with Traject. He is a designer, a technologist who can make prudent design decisions based on scientific reasoning and empirical data, using state-of-the-art parametric simulations, especially in the areas of daylight, heating and cooling demand, annual energy consumption, and much more. I am very much happy to welcome you, sir. Looking forward to the session.
Hi, Lukash. Thank you for having me.
Yes, sir.
Can you see my screen? Can you see my
Yes,
screen?
sir. Yes, sir. Yes, sir.
Oh, great. Good evening, everyone. I'm Prithvi. Those who don't know me, like you said, I graduated in architecture in 2016, and I worked for a year with Varsha and Pradeep. And after pursuing a master's, I'm working as a building performance analyst with Traject advisors and managers. So Traject, we have a group of advisors, consultants, and project managers who work with varied projects. We have 6 teams ranging from sustainability to project management, and we address each and every step of the project with more vision towards sustainability. And I'm working under the team called Energy and Technique, and I'm happy to be here to present. So what I do is I try to give a general overview of what I'm trying to present today. So I'll give you an idea of what building energy modeling is and what kind of tasks I'm doing here, and what is performance-based architecture and what in an Indian context. And I would like to go through some of the basics calculations like sun path, understanding sun path, and how you can design a better shading system. Because I believe like all these concepts are quite huge, but they all start with very simple basics stuffs. And I would also like to show some of the case studies and projects which we have been working on. So what is my role in the company? It's more of assisting architects, developers, and engineers to understand what kind of impact their design decision is going to be. So I can help them to make better design decisions if they know what they are going to do or what kind of situations they are going to lead to based on their design. So what is the general aspect is the first, we have a simulation software, and for the simulation software, we need a certain set of inputs. And the first one is the weather file. So weather file is nothing but you have meteorological centers all over the world, which collects your dry bulb temperature, your humidity, and your solar radiation, and all such stuff for throughout the year and on an hourly basis. So it's roughly around 8,700 hours. So in my role of work, so I usually start with studying and understanding the weather file. Then I go to the building geometry, which is provided mostly by the architects, and see what kind of design they have come up with, and start putting thermal properties for each and every part of the components, like for the glass, for the walls, roofs, and stuff like that. So we put all these things in our simulation software. We work mostly with Design Builder and Grasshopper based on the position or based on the design stage of the project. And we can create n number of outputs, starting from shadow study, or like overheating calculations, thermal comfort analysis, and much more. And most important things are we can simulate multiple energy concepts, because as a company, we have people with more than 25 years of experience who can come up with very interesting energy concepts to attain net neutrality. So one of my major work in the company is to prove their hypothesis or disprove their hypothesis on what basis their solution is going to work, or on what basis their solution might not even work. So this is what I generally do in my company. Based on Indian context, India has drafted a plan called India Cooling Action Plan. So we all know global warming is happening, and we need to create more passive strategy buildings. But what has been done in the government side? So they say that office spaces are going to consume or going to increase more than by 2/3 in the next 20 to 30 years, and the cooling demand is going to increase almost by 8 times. Well, you can see in the graph over here, the energy consumption is mostly from the HVAC systems, and we need to design much better solutions. And with the Indian Cooling Action Plan after drafted, they say they are believing we can address at least 25% of the demand can be met. But again, these are next level stages or high level concepts. But what has to happen is we have to come up with, we should take one step back. So there are like several ways, or there are not too many ways to design a sustainable building. So it's just a simple approach. You start with designing a passive building, and then you go for a smart HVAC installation. Sometimes you can address the building without any installation concepts also. Those are really great actually. But most of the time, especially in office spaces or in big commercial buildings, you end up putting HVAC systems. So the idea is to start with a passive design building, go with a smart installation, and then think about what kind of energy production or renewable energy you can come up with. It can be a PV or solar farm and stuff like that. But most of the time, what happens is we always skip the part one. And if you have an ambition of trying to do the step 2 and step 3, we end up with something like this. So both these buildings are, we can call it as energy neutral building, but whether you're going to make it as an active design or passive design, that's up to us. You can see both the buildings has similar energy performance, but for obvious reasons, we can see that passive designs needs to be promoted and needs to be pushed. So that should be our step 1. And then you address how much amount of installation you are going to put on and how much amount of solar panels or renewable energy you are going to address. So start with your passive design. So there are many interesting examples, just for like performance-based architecture in India. So I have put the link in description over here. This is some research paper which talks about what are the different parameters or what are the different values they have used in order to achieve this. And so you can see most of them have less glass percentage and better shading system. So you can just check out these projects in the description. But what I would like to talk is, there are n number of factors that an architect needs to consider to design a building. And at the same time, there are numerous variables which are going to affect your energy consumption. But it seems like a lot, but if you ask me, there is very few aspects in terms of energy consumption that an architect can address, which is mostly with the orientation of the building and how you treat the skin of your building. If you address these two properly, you can almost solve most of the energy consumption issues and create a much sustainable building. So the basics is what I believe is, I think we would have drawn this like more than like 50 to 100 times in terms of understanding the solar part. So I would like to give you a brief or a detailed understanding of how a small sun path works. So yeah, as you can see, this is the sun path from a plan view. You can see these lines or actually the months. So this is the sun which travels this way, and these are the months, and this is the time. But if you see it in section or in terms of an elevation, you can see the sun reaches its high point over here in June 21st, and sun is low at December 21st, winter solstice over here. But this is something which we always see in terms of a two-dimensional aspect. But there is an amazing guy called Andrew Marsh. He has created multiple open source tools. For example, something like over here, which gives you a much better idea of how a sun path works. So for example, if you see over here, if you see over here, so this is what I was talking about. Having a two-dimensional sun path is always confusing, and sometimes we don't infer proper data from it. So what you can see is, you can see over here, this is the timeline where it varies from day till night, or you can see how these things work in terms of different months. For example, let me put the time somewhere in the center. Yeah, somewhere like here. So here you can actually see the relationship of sun path with respect to your building. So if you see in terms of, let's say, in terms of side elevation, you can see irrespective of winter solstice, the summer solstice, which is over here, where the sun is at its highest point, or winter solstice, sun is really high in India. So there is no point of saying that during the December month, we are going to let in more light in But in nature, you have to cut down radiation from the sun, irrespective of whether it's summer or winter. So you have to design your shading systems or glass percentages accordingly. But this thing is not common in the Netherlands. You see over here, you put it over here, you can see why winter sun is very important over here. Netherlands is more of a heating dominated country. So that means during winter, the sun can go really low, and it is very, very important to let as much as heat inside the building to passively warm up the space. Well, that's not the case in India, or especially in Tamil Nadu, that you can see that the sun is always high and it's going to be really hot. So what I'm trying to do is understand the solar path in a three-dimensional way, which helps you and better understand the position of your building, from where the sun is coming from, and stuff like that. And this is one of the reasons, like you can see, especially from the north side, since we have sun on the south, and you can clearly see that the north is always shaded. And this is why we always opt for putting more glass or creating more open spaces in the north, because we don't receive direct radiation on the north side. Okay, so I hope you have the bit better idea or understanding about the sun path right now. So what is the next step is this one. Once you have an idea of what a sun path is, the next thing is to understand the sun shading chart, which is here. So this is basically, imagine you have a window. Let's say you have a window over here, this one, facing south, or let's choose this one. Imagine you have a window facing south. If you look at from the window's point of view, like from the perspective of the window, the sun actually moves in this shape. Similar to the solar path, you can see that these are the different months, and this is the different time from 7 to 17. So this is how you project your sun in terms of sun shading chart. And all these points are nothing but the 8,700 data of sun just being measured each and every time. The radiation of the sun is measured each and every time. What is very interesting about this chart is that you can see if it is red, that means it is hot and the surface or the window needs to be shaded. If it is yellow, that means it's comfortable, that you don't need to shade your structure, or at least to a certain extent. But what can you see from this chart? So as I said before, so this is the months. So that means this line is December, and this is Jan. So this is, let me put it the other way. So this is January. So this is Jan, Feb, March, April, May, and June, and then it comes back July, August, September, October, November, December. So sun almost comes to the same position twice in a year. As you can see, this portion is kind of yellow. Why do you think this part is yellow or this is comfortable zone? It's because it's during December and January, and especially in the morning time from 7 till 9:30 to 10ish. So this part of the chart is, or this part of the sun is really comfortable. So once you understand how this sun shading chart works, the next step is to design the shading system. So to design a shading system, they have an amazing open source tool called, this one. This is called Climate Consultant. So I'll just show you how to open this thing. Let's say you don't like it, I'll put the link, send the link to ma'am so that you can all use the software. So you open the Climate Consultant, then it asks for start a new project. So you load your climate file into the software. You can find all the climate files over here. So if you go to the energyplus.net/weather, you can go to India. So I'm using a data from Trichy. And if you load those weathers into the climate consultant, it looks something like this. So I have loaded the weather data of Trichy. So as I said before, for every hour throughout a year, all different kinds of data like solar radiation, diffuse, direct radiations, dry bulb temperature, wet bulb temperature, relative humidity, everything is recorded. But it's really important to understand each and every definition of what it actually means. And they have a really good user source or help help desk or a user help you can use. And there are a lot of tutorials on the internet which you can go through to understand how a weather works or how a climate file works. Because we really need to focus more on locally or climate sensitive architecture. So that means you have to understand the weather much better. So once you go through this, you can see different kind of representation of data, like in terms of temperature, the diurnal variations, what kind of radiation is there every month, or what is the sky range, velocity, the ground temperature. So for example, if you go 1 meter below the ground, so if you go 0.5 meter below the ground, it's around 24 degrees. So you can use any other passive techniques like using pipes to ventilate the air. But what I'm more interested in showing you is this one. So this is what we discussed before. So this is a sun chart. So for example, you can click display grid or display shading calculator. So what it does is, imagine this is for the south facing window, and this one determines the angle of the window or the length. For example, this is 10 degree, 20, 30, 40, 50, 60. Once you create the shadow range, let's say over here, so you can see the numbers changing. So without any shading, it says on the south facing window, you have almost 1100 hours exposed. So that means your building is going to overheat. So you start reducing it to a certain extent to understand at what particular degree that you should stop with your shading system or the angle of your shading system. Let's say I'm putting it over here. So this is what it is. It's around, let's say, approximately 55 degree over here. What this 55 degree actually means is, imagine you have a building when this one is facing south and the window height is 2 meters. You have your horizon, and this is what that 55 degree means. So if you have a window, let's say by 2 meter by 2 meter in height and width, so you have to put this angle at 55 degree so that you can reduce the amount of hours exposed, which is 55 degree over here. That means we have the length and we have the remaining angle 35 degree. We can just use a simple trigonometric calculation to find the length of the horizontal shading system. Similarly, a south facade also requires shading from the east and west. For example, let's say you balance this at 60, let's say the radiation coming from the west, because we know that the radiation coming from the east after 55 degrees hardly any, because of the cold winter, typically not winter, but let's say during the December and January early mornings. But over here on the west, you can control the degree of the shading system. Let's say I'm putting at 60 degree or 30 degree. That is what happens over here. So you have a 2 meter window and you take 60 degree approach over here from the center, and you design a shading system of 60 centimeter. So if a normal window of 2 meter by 2 meter requires at least 1.4 meter of shading in horizontal and 60 centimeters of shading on the west. So this is how you can always go for some complicated parametric simulations or many of the stuffs which many of us does. But it's always important to understand the root values or the root basics and use simple open source tool to start with the concept. Maybe once you have an idea of, okay, this may not be like 60, maybe you can achieve the same effect with 50 centimeter and things like that. Then you enter more complex calculations. But just to get an idea, use these tools to understand what kind of angle or what should be the length of the shading system. And similarly, you can move this chart. Let's say I'm putting on the west side of the window and see what should be the angle of the windows. And you go to the east and measure the angle. So if you see in the sun path, so the sun probably from the east, I guess. Yeah, sun from the east needs only the shading system probably on the left side, probably on the west side or similarly. So the east and west requires one vertical fin on opposite directions with the horizontal shading. Well, this is entirely up to the architect, whether he needs to, let's say he puts the east and he designs a horizontal shading system, or he has some other ideas. So these things are up to the architect's creativity and what they like. Well, my job is more of assisting them to understand their design or understanding the impact. But imagine if you have a long, so this is your typical window. Imagine you have a long shading or long glass. You can't design, it's not practically to design such a long shading system. So you break them into multiple points over here. So these can be anything. So you can design a jolly wall, sometimes it works. I think our campus has really good shading systems, and yeah, be creative. So you can do whatever you want with this one. So once you have an understanding of the shading system, we all know that the best orientation is always east-west, and we can put more glass on the north and a bit lesser on the other three sides and design a shading system. But you won't get projects or the site access with this thing all the time. So you might even need to put your buildings, let's say, in terms of north-south orientation, which is not preferable, but that's what the site is all about. That's due to the, let's say, constraints of the site. But still, you can design a better shading system and choose appropriate glass percentage on what side and how much you have to produce. Again, let's say you are designing a showroom or like a commercial space where you are mandated like to put a lot of glass, and so that you can show what is happening inside and stuff like that. But still, you can design a better shading system to avoid most of the issues. Of course, the best solution is always with less glass, but based on the programs and based on the orientations, you can vary these things, but design a better shading system. Don't end up just putting a glass box everywhere. It's going to look exactly the same. And this is not what we talked about. Always start with the passive shading system. Once you have an idea of what kind of shading system you are going to design, look at what are the glass options you have. You have single glazing, you have a double glazing without any coating, you have double glazing with the coating, and then you have triple glazing with coating. So these are the general most common glasses you find in the market. Well, I'm going to help you to understand how to read these things or how to understand the basic values in it. For example, any glass, you take a brochure or if you're going to put anything, there are three factors which you need to see: the U value, solar factor, or the G value, or the light transmission. U value, so heat transfers into a space through conduction, convection, and radiation. U value is all more about conduction. So it tries to put the heat or the cold within the space and try to minimize the heat loss that it's going to escape. Whereas G value is more about radiation. It tries to keep the heat out, especially in a country like in India, where we have a lot of heat, where we have a lot of cooling demand. We always try to keep as much as solar radiation outside. So always look for a lower G value and a lower U value. But G value plays a major factor than the U value in respect to India. Whereas in the Netherlands, U value plays a huge factor because you have harsh and cold winters like up to -10. In those situations, you can't, it's not advisable to keep the sunlight out, but allow more radiation inside and minimize the heat loss by putting a lot of triple glazing or something like that. And one last factor you also need to check is light transmission, because lowering these values is going to lower your light transmission as well. So see where the balance is and try to read these things. So a good shading system and a good glass should be more than enough, at least to give a better start. Of course, there are many other variables, like you have to look into your thermal mass, you have to look into what kind of local materials you are going to use. But in this presentation, I just want to give a good opinion or good understanding towards the glass and the shading system. So like we discussed before, step one is to start with the design a passive building before moving on to renewable energy or smart installation concepts. So what we do in our office is help architects to optimize these passive design strategies. So like I said before, we have different types of glass percentages based on the orientation, different types of insulated glass, whether the glass is going to let more heat in or not more heat in, or you work with the building insulation. In Netherlands, we need thermal mass, at the same time we need insulation. So the difference between them is thermal mass is more like a battery. You can charge it to a certain extent during the day, but after a point you can't just charge it. The heat is going to come in. So that's why in India we always push for more or high thermal mass, where it takes more time to heat up the wall. Before the heat comes in, it's already night and the outdoor air temperature is cooler, so the temperature goes up. But the idea of insulation is more like a polythene cover. So if you pour water or heat in it, it just stays over there and that's it. The amount of transmission through an insulation is really low. So in Netherlands, we balance between the insulation and thermal mass, but I think in India, we can put good or heavy thermal mass to create better and good comfort. And like we discussed before, there are various kind of shading options. So you create the zigzag options between all the variations. So you have a range of parametric options of a range of parametric designs from more glass to less glass with shading. Well, few of these things are better in terms of energy performance. Of course, this is better in terms of energy performance than this one, but it looks like a communist or Soviet building. But as an architect, he would like to have his options of balancing the system. And well, in terms of daylight, it works the other way. Well, the optimal solutions are always somewhere in the center, not to that extreme or not to this extreme. So this is what we try to do in our company, that try to create multiple options so that the architect has a framework. He has a framework to work on, okay, to see what kind of options he should go for, or how much amount of glass he should go for. So, and one of the major reasons for building energy modeling is to attain an optimal balance between low energy consumption, balance the daylight, at the same time balance the thermal comfort, included with cost and many other aspects. But if you are going to balance multiple, most of the engineers over here in India can do one thing just because of their mere experiences, which is really possible and which outdates the simulation. You don't really need complicated simulations sometimes to balance these aspects. But if you're going to put more variables like energy, daylight, thermal comfort, cost, and many other things, it is required to have a good or a better understanding of the simulation software to achieve the optimum. I would like to just give a brief idea of what kind of projects you're working on. And this is a mixed residential building in Arnhem in Netherlands, designed by Renewable. So you can see here, this part is completely offices, and this is living spaces. So architect has an initial idea of putting more glass over it. So the first thing we started is to start reducing the glass percentage. And especially in the Netherlands, if you see, even though north is desired in India, the problem is in the Netherlands, you don't get any sun. You won't get any sun from the north. So that means during winter, you can't use any passive heat, which is entering the building. So we started with optimizing the glass percentage on the north for start, and worked on the south. And as you can see, one of the major buildings' visual identity is the fins. Like I discussed before, we sat with the architect and we helped to see what kind of balance between the fin distribution and the fin length would help the design. So you start with the basic understanding, and then you enter the simulation for a complicated or more detailed analysis. So we worked with thermal comfort and peak capacity calculation for this one. And this is one of the government offices in the Netherlands. So this is an existing project, and they have a huge glass atrium. And here they had an issue of overheating. So it's very weird to see in such a cold climate that causes overheating. But due to the global warming and stuff like that, we are having more than 35 to 40 degrees in the Netherlands. And this huge glass space is facing south. And we calculated with the total energy consumption. Then we started understanding, okay, so you're going to have a more issue of heating. So what are the solutions we can put? So in this case, since it's an existing building, the more financial advice was to increase the airflow in the space to address the overshoots. But you can also design other passive strategies like shading systems or solar screens and things like that. And this is one of my favorite projects as well, this is the fourth tallest tower in the Netherlands, which is still in development, which is HS Ontwinkel plot from KCAP. So what happens over here is, you can see it's a high rise. And designing a shading system, let's say on the 20th floor or 30th floor with vertical fins, is more expensive, and sometimes it's hard to construct as well. So we need to find a suitable way on how to address the overheating issues in the apartments. In the Netherlands, we have a strict regulation stating that only these many hours an apartment can overheat. So we need to sit with the architect and find the right balance. So we came up with different options. So this is north. So these are the south-facing apartments. let's say we started with putting a lot of glass in all the apartments with good glass specifications like the U values and G values. Then we put a low glass configuration and we try to optimize the difference. But after running the simulation, we found out that the southwest or southeast corner apartments are going to overheat, whereas the other apartments facing north and things that are better during the summer. But this is not applicable and we can't go through building permit. So then let's say then we put less glass and put better glass values. That means we are wasting too much money on the north side because these spaces are never going to overheat. So what happens is we optimize. Then we try to optimize the difference of glass percentages based on the orientation of the apartment. And then we see, hey, maybe the southwest apartment doesn't need a lot of glass, but just reduce the glass with better G value and the rest of the apartments can stay same. So this one configuration kind of determines the language of the facade or language of the skin. So this way, the architect, like this is the output. Like similarly, we created almost 20-30 options to the architect where he can choose how his design should go. And since we had the project at the concept stage, it was very helpful in terms of optimizing these things. And one of the and of course, once you understand what kind of glass percentage you are going to put based on the thermal comfort, then you work on the daylight simulation and see what kind of glass percentage is better or is more suitable. So putting more glass or less glass and understanding the light transmission is very important over here. And finally, since most of the buildings needs renewable energy over here for their approval, the thing with high-rise buildings are they don't have much of space to put PV panels on the roof because it's one vertical tower. So we did a solar radiation analysis to see the impact of sun's radiation on the facade and see what are the best spots to put our PV and where we can optimize our energy production. And yeah, so you might have a lot of aspects, but passive design is the key for the sustainable future. And that's what we push in our company. And but this is hardcore engineering almost. But being an architect, I think you have an idea of everything and you can easily specialize in one concept which drives you the most. For me, it was climate engineering. But if you are someone who's passionate about the engineering part of the architecture, there are other courses or other fields where we need architects, like facade consultants or parametric designers, even structural designers, BIM modelers, and daylight specialists. Being an architect helps you understand the story from both the sides. Not all the time architects are right, but sometimes engineering has its limitations. So trying to balance, if you wanted to understand both the balance or both the benefits and disadvantages, choosing an architectural engineering profession, something like this, it's more helpful. And this is the presentation. You can contact me if you have any doubts in terms of simulations and stuff or any other advice. Thank you.
Thank you, Prithvi.